welcome to the Earth Building event, Building with Earth. This is run by ACAN, the Architects Climate Action Network, which is an organisation of voluntary network made up of professionals from the built environment. Started a couple of years ago with a small group in London, but it's now a global network of over 3,000. And we've been doing a lot of work on responding to the climate emergency within the profession in our different work streams. ACAN has three main aims. Firstly, to radically transform the regulatory, economic and cultural landscape in which our built environment is made, operated and renewed in order to facilitate rapid decarbonisation of the built environment. We want ecological regeneration, the immediate adoption of regenerative and ecological principles in order to create a symbiotic relationship between buildings and the natural world, prioritise communities and ecosystems at threat, and promote the recovery and restoration of our natural environments. We also want cultural transformation, a complete remodelling of our professional culture. We must challenge and redefine the value systems at the heart of our industry and education system. We seek to create an open network to share resources and knowledge to aid in this transition. ACAN has many branches to it. We've got, currently there are 9 main action groups, and each of these groups are putting out lots of information. There's lots going on, and there's opportunities for anyone interested in any of these particular areas to join an ACAN group. The Natural Materials group is just one of those, and this is this event series is run by our group. So without further ado, with slight further ado, sorry, we are doing a call out to ask if you might consider donating. It is a voluntary network that we're running, so all of our overheads need covering, and these events help pay for ACAN and help us exist. So if you would consider setting up a donation, that would be really, really appreciated. So now moving on to the speakers, we've got 5 speakers with us tonight for our Building with Earth event. First up, we're going to hear from Rowland, Keable, and then Tom Morton, Becky Little, Paul Mallion and Claire Whitney. Then at the end of the event, we'll have an opportunity for Q&A. We anticipate this will be about 15-20 minutes at the end, but we'll see how timing goes. And we're hoping to be finished by 8:45. So first up, we have Rowland Keable. So I'm going to stop sharing my screen and hand over to Rowland.
Thanks, Janet. So I'm just going to, hello everybody, I'm Rowland Keable. I'm just going to share my screen and off we go. Where are we? Right, so I've been given the job to introduce Earth Building sort of generally. 15 minutes isn't really enough. You know, I'd like the full hour and 45 minutes, but there you go. Yeah, I'm quite well known for work that I've done with Rebearth over the years, but I also am CEO of EBUKI, Earth Building UK and Ireland, which we set up 2008, 2009. EBUKI was a way to bring together all of the earth interested people, because you can't just have the earth interested architects or the earth interested engineers or surveyors or builders. These groups would have been too small at that point. It's probably a little bit different now. But if you get the earth interested architects, engineers, surveyors, builders, developers, others together in the room, then you can have an interesting conversation, and you find that there are, you know, there's lots of kind of cross-pollination. So that was the idea. And then over the time, we've developed quite a lot of policy, and we've run quite a lot of events, and we've got a certain amount of social media and website. I'll talk a little bit more about in a while. And we're also the UK UNESCO chair for urban architecture body. So we have quite a good network across Europe and the wider world within that UNESCO chair. And that essentially means that we have to report every couple of years and tell them what we're doing in terms of our activities and the education, how many students have been taught in what disciplines, and so on. So and that's quite a nice active network as well. So I'll just start with a few common questions about Earth. It's generally seen as there isn't an awful lot of it. It's rather old-fashioned, but in the work that we've done on a project called Keable, which is looking to make cob technology or mass earth technology meet UK and French thermal regulations, we looked at EPC data for the sale or rental of earth buildings, and we came up with this little map, which shows about 12,000 houses have sold or rented since the EPC system started in 2005. So it's about 1,000 house sales or rentals a year. And you can see that there's a lot of it focused down in the southwest, but there's also quite a good distribution across the rest of England and Wales. It's a little bit more difficult to get hold of this Scottish data. And this actually is quite out of date now. This is 2018, I think. So I think we could probably fill this map up a little bit more. So yeah, there's quite a bit of it. You kind of need to have your earth building glasses on in order to see it. You know, one of the questions I'll just answer now, because I know everyone always asks it, is how high can you go? So these two buildings don't look particularly Earth-like. And many of the earth buildings in the UK don't look particularly Earth-like. They've got renders on them or different kinds of finishes. But these two are, on the left-hand side is in Lyon, and on the right is in Germany, and they're sort of 6- and 7-story round earth structures. So we know you can go high, and obviously if you were building timber structures and infilling them with earth, you could go quite a lot higher still. And again, these are both in kind of urban settings rather than rural. And this thing about urban and rural, there's quite a lot of, you know, we get quite a lot of, oh, this is something about the countryside. This is something about one-off houses. This is something about, well, in Australia, you know, it's seen as being very sort of upmarket. These are social housing units in Germany, and they're a mix of materials. So there's quite a lot of timber in these, but they're in the common parts, they are largely earth built, and they're earth built because it doesn't burn, and it's a very good absorbs sound very well. So they're using earth for what it's good at, and one of the things that it's good at is mixing in with other materials, other building types. So normally I'd be talking to you about a whole lot of other things: sustainability and heritage and health and well-being and supply chains and training and codes and networks, but I don't have the time to do that. So I'm just going to start with just a few types, and then a little project that I'm working on at the moment. So you have a number of different earth building types. Again, they're quite complementary. You can use mass earth or cob or mud wall, depending on which part of the country you're in. with lots of other different building types. So this is a building in Sligo, north of the Republic of Ireland. It's cob and straw bale largely. And then you've got framed earth or wattle and daub or mud and stud, lots of different names for all of these technologies. And we're trying to, as an organization, give them non-vernacular names. Not that we don't like vernacular names, but just that we don't want to say that mud wall is the only way of saying something if the people who think about it as cob are going to be asked. So framed earth are timber structures with infills, lots of different ways of infilling timber structures, and obviously a very common way of building in the past. And it's one of the sort of Cinderellas that really needs lifting up and doing a little bit more of. And the way that a lot of this has happened in Europe, particularly in Germany, in the last sort of 10 or 15 years, is that framed earth has been really championed with light earth. So light earth is a clay slip which binds together a lot of fibre and makes very interesting thermal performance, and then it's filled in around a timber structure, so like framed earth, but with a much lighter mix. And this is actually the mix that we're using in combination with mass earth for the Cobauge project. And then you've got molded and compressed earth block, and I'm not going to talk that much long about it because I've got a little bit more to say in the project that I'm working on currently, but you can do masses of stuff with molded and compressed earth bricks, and people have done all over the UK, all over the world. It's a very easy transfer thing because people think that they understand brick and block. And then Tom and Becky are going to get me a better turf image to be showing. But you can see on this a kind of herringbone pattern just faintly in the turf. And turf was very widely used across, particularly, I'm not going to draw a line around it, but turf is one of the global earth building methods. It's having a bit of a revival now in the UK following a lot of training and connection with other turf builders in Iceland and the Netherlands and elsewhere. And then you've got earth mortars. So obviously earth mortars sits with unfired blocks and bricks, but it also sits in this case with stone. So when you look at a stone building, you kind of go, oh, that's a stone building. But actually, when it's clay mortared, and many of them, a high percentage of stone buildings are clay mortared, then we would claim them for ourselves, because actually the geometry of this quite high status Georgian building is really managed by the fact that it has a mortar, and that mortar is clay, and that's a locally sourced and very easy to use material. And then there's rammed earth. This is a public building, done quite a lot of public buildings over the last few years with rammed earth. It has a particularly look to it, and I think one of the things about earth building is that it is very, very diverse. The buildings that I've just shown you and this one all look very, very different, and earth is something that gives architects a lot of opportunity to do all sorts of different things, including just putting a finish on it. Claire will talk more about this, but this is the Apple store in Brussels, which is clay plastered and gives lots of benefits, which she's going to talk about, no doubt. You know, it's either as a flat single finish or as a 3D and color decoration finish. Lots and lots of things that you can do with clay plasters. And finally, in the types, this is about floors. Clay floors can be put in a number of different ways. This has been done wet, and you can go and have a chat with earthfloors.co.uk, but other suppliers are available. They've done a very nice trick here with a very dark finish. They've managed to get a molded earth block wall to look like it's floating. So yeah, quite a number of different uses, quite a number of different technologies, but they all kind of work quite well together. So yeah, my background is rammed earth, and but that's slowly changing. So I've got some different things happening. So new projects, new directions. This is a site that we're on in Walthamstow in northeast London at the moment. And you can see that there's been quite a lot of demolition, and that all of the materials that have been taken out of the demolished buildings have been saved where they can. But there's also piles of crushed concrete and soil and other things. And the developer has said there will be no skips. And this is like a major change, because we all know a lot about waste in construction. And so when the developer says no skips, that really heralds a big change, I think. And so these materials have been processed using site tools. So on the left, there is a crushing unit which crushes concrete and brick into to gravel. And on the right hand, there's a rotating screen which takes out the larger elements. So a whole lot of material was processed on this site, and then it was taken to a brick manufacturer. So on the left-hand side, the brick manufacturer is screening again. You can see on the right of that image, there is some quite coarse material that hasn't gone through the screen. On the left, in the foreground, there is some very coarse material which will be crushed again. And towards the back on the left-hand side, you've got the fine mix. And that fine mix has been made wetter, had straw added to it, and the blocks on the image on the right are the product of that. And so they will be, so that's clay taken from that site, further processed, made into blocks, palleted, and that will be taken back onto site again and used. And I'm afraid the program there is a little bit behind because of supply chain issues with timber. They've got plenty of clay and clay blocks, but the timber has slowed them down a bit. And the image on the right-hand side, so this is about party walls. So these are not walls that are out in the weather at all, but they are fireproof and they are soundproof, and that's why they're being used where they're being used. And the image on the right is of some handmade trial bricks and mortar, just for the developer to understand what it was that they were getting. So that's quite a change for me, and it's also quite a change for the developer, and it's quite a change for the brick maker. But everybody wins in this, because the developer doesn't have to pay landfill tax, doesn't have to pay muck away. The brick manufacturer isn't using up their own store of clay, and the building itself will be extremely responsive to temperature and humidity and lots of other things. So how do you begin as an architect, or really as anybody, to think about earth building? How do you break it down and think about all of the different elements? So we've done quite a lot of policy work over the years, and these are learning outcomes for, in this case, level 5. So under the European qualification framework, architects are level 7, but this works for you. So if we look at this first one on building with earth, there's knowledge and skills, and it's basically a checklist for you to think, I don't know, do I know what he's talking about? Advantages of earth and materials from a local and global sustainability standpoint, embodied energy, carbon intensity, recyclability, toxicity, transport of extracted material, use of water, use of raw materials, socioeconomic benefits versus financial costs. Okay, if you don't know what any of that stuff means, then you need to go and find out. But if it starts to mean something, it's a very good checklist to to work out whether you are achieving those goals that you want to using materials which are locally available and low energy. Janet, have you just popped up because I'm going on too long?
You've got a few more minutes.
Few more minutes. Okay. So this is the build unit, and then this is economy. So this is like selling it in. This is marketing. This is insurance. This is all of those difficult things, which is about earth building business. And so it's things like how to integrate earth into conventional construction rules and situations. And so if you think about that, just the top line of knowledge from the E unit on the project that I've just shown you, how to integrate earth into conventional construction rules and situations, you can see that it's actually not that complicated. Once you start to think about it, these are all just built elements that everyone's familiar with. It's just one small change that they're not fired. But how you get the materials processed and made into other, into new materials and then used, those are the things that you have to understand. I said that 15 minutes isn't enough. It's not enough. But anyway, I just thought I would show you 3 of these units because it's all available online for free. I'll give you the link later. But this is the mix. And mix is really important because one of the things that we're really looking at is using materials at or close to site where we can. And so this takes a little bit of a slightly finer grain approach to this. And saying, okay, I found a load of chalk on my site. What can I actually do with chalk? Does it lend itself to this? Does it lend itself to that? I've found London clay, solid clay. Does it lend itself to round earth? Probably not. So it's about kind of looking at what you've got and then using it for what it's best used for, rather than saying, I'm going to build a round earth building. I'm going to build a mass earth building. Look at the material first, understand it, then make the decision. It's a slightly different way around of looking at planning of a building, thinking about your architecture. But it opens up. It gives an enormous area of creativity to work in. So sources of help, getting involved. Earth building, like all of the natural materials, needs involvement. It needs people to get involved and to understand what they're doing and having those conversations and sharing that information. So that's why we set up EBUKI, and there's a website and there's a Facebook page, and you can kind of go and look at that stuff and you can get in touch with people. If you look at the resources button on the EBUKI webpage, there's a lot of policy stuff that we've written, research papers, loads and loads of stuff to get your teeth into. And then we've got local groups, earth building, Ireland, Scotland, Wales, again, places to ask questions. And obviously there are other places to ask questions too, like Talking Natural Homes and so on. But this is the little groups that we've set up. And that we're also very involved in the Earth Build Europe group. That's where we've developed a lot of the learning outcomes that I showed you, and that's what's led to the establishment of the National Occupational Standard, and the ongoing work on standards and policy work with our European partners. And then we, as an organisation, are reaching out a little bit further than that, and we're trying to establish a little group in Zimbabwe to think about how they network, because what we've seen in the UK is that having a network is a very positive thing. It allows you to do lots of things which working as a single company or individual isn't possible. And that European network of groups is something we'd like to see happening in Africa, so that Zimbabwe, Zambia, Malawi, and so on could also work together with each other. So that there's quite a lot of things going on. A lot of earth building isn't about earth building, it's about building that resilience within the design and build sector, growing that understanding so that you don't get a completely blank look when you say, let's do this with earth. Thanks for listening. Please do get in touch, and yeah, hopefully there'll be some questions later.
Oh, thank you very much, Rowland. That was really good to hear. We are now going to have a go at running a poll quickly to understand a few questions from our audience. Emma, are you able to run the poll? Are you there, Emma?
The poll should have just gone live, so
yes, it's just started.
Excellent. Okay, so you should see a poll now, and we'll just give you a minute to answer the questions. Is everybody able to see that?
We're having some answers in the chat, but yes.
Okay. Good. I'll just give you a minute to answer the poll questions.
For question 2, we mean 1 being a low knowledge of natural materials and 10 being a high knowledge, right? Just to clarify, yeah.
Yep, thank you. We've got some questions coming in the chat box as well, which is great because we'll come back to them at the end in a Q&A session. So if you do think of anything during the event, please do write that in there. Okay, I am actually not able to see the poll in front of me. So have we got to a point where it's completed, or should we wait a bit longer?
Yeah, I'll end it now.
Yeah.
Amazing. Thank you, everyone who answered.
Yeah, thank you for that. And we will now move on to our second speaker, who is Tom Morton. So Tom, you are going to be made unmuted, and we'll ask you to share your screen for your 10-minute presentation.
I'm trying to share my screen.
Are you on mute?
There we go.
There you go. Yep.
Is that it?
That is working.
Excellent, thank you. So I am just going to rattle through some case studies. So I'm an architect in Scotland and work with earth in various ways. And the easiest way to talk about it is just to show you some of our stuff. I'm going to start with turf because it kind of brings together all the fundamental aspects of earth building. And when you build with turf, basically you are digging up the topsoil in this way into blocks. There's in Iceland, where all they had to build with was turf, it became a very sophisticated thing, and they built for hundreds of years complex buildings made of turf. But in Britain, because we built in lots of different ways, the turf building was fairly simple arrangement. And a turf block, then, essentially, it's a mixture of minerals and fibres. So it's a composite earth fibre block. And here we we're reconstructing a building from the 17th century, and this just shows you the size. So effectively, it's a masonry technique, building up in courses, any kind of mortar, masonry, but without mortar. And it's kind of got the consistency of the way to describe it, and you can cut it with various tools, and so you form it in courses with a herringbone arrangement, so that as it shrinks and compacts, it keeps tight perpen joints. And you can dress it around corners various ways. And so with this building, it has an internal timber frame structure, and around that we wrap the turf building on the outside. And the interesting thing is that when we did a U-value calculation on this wall, which is a replication of a 17th century wall, we found that it complies with modern thermal standards. So in many ways, it's kind of back to the future with these materials. And it's minimal transport, minimal processing, because all we had to do was wheelbarrow it about 20 yards. So that's the walls finished and the roof ready for its air. And the next, and of course, we put turf on the roof as well. So these are thinner divots, which see being thrown up there. These are only about 3 inches thick, are then form an underlayer for the heather thatch. And really, when you work with traditional techniques and materials, a lot of the same principles for modern sustainable construction apply in terms of low amount of energy and resource use, the use of natural materials, but also the skills and knowledge that come with those. I'm just going to sort of have a slight detour into Bob, which we also used on that project. And this shows the range of different earths that were used to form the daub. And in this case, the most efficient way to mix this on site was in a skip with the bucket. And
so this is our daub mix. It's a bit like a thick fibrous plaster that goes onto the woven wattle, the hazel weave behind. And the mix is made using subsoil, just from site. That's the bulk of the mix. It also has a bit of clay in it. Ideally, we'd have got clay from the river just here, but we can't dig because it's a triple SI, so we've had to bring in a little bit of clay from outside. And then some straw, chopped straw, and some bit of longer straw as well, combination. We mixed it in a skip using a digger, which is obviously not traditional. It might have been using horses, or a village might have got together to mix the mud. And then once it's in this kind of really fibrous but soft state, then we can apply it to the walls. So, yeah, and I mean, most of this is done, but it's just a case of using your hands, working it in. The plan is to probably give it a bit of a top coat in this room, because this is a slightly finer room. So we'll do something similar but finer. We'll just give it a little bit of a skim coat by hand. Should be quite a quick job. And then after that, the plan is to maybe put some lime wash on it.
so the thing with daub is, right, you know, you can see it's well not fashionable and barely anybody does it, but it is actually a fantastic material to work with. And actually the feeling you get when you apply daub, it's a wonderful way of building, just as a sensory experience. And you can see that, you know, with touching with your hand, there's no toxicity there. It's fantastically malleable, you know, as a kind of sculptural, subtle surface you can achieve. So that was a slight diversion. Onto more contemporary buildings. So we've done a number of buildings using blocks. And so this is a kind of a low-cost eco-house thing built to affordable housing standards, and it's very much a standard family home. Here, so it's a timber frame construction with an inner face of earth bricks in earth mortar, which were then clay plastered. So it's kind of, in a way, it's the reverse of the previous building, which had the timber on the inside and the earth on the outside. This is the earth on the inside and the timber on the outside. And so this is the construction. So the structure is in the timber frame, but the thermal mass and the moisture mass and the acoustic insulation is on the inside. And then you fill the cavity with blown-in recycled newspaper insulation. And these bricks were made in a local brick factory, and we finished them with a proprietary clay plaster. Here, most of what I'm talking about in our projects is materials rather than products, materials that we've made ourselves for projects. So this was part of a research project where we monitored it thermally and in terms of moisture every 30 seconds for a year. And it was what we found was that while the paper U value for the building just complied with regulations, the actual performance in situ was 50% better because of the thermal lag effect you get from earth and materials. Another important benefit was the regulation of internal air quality, particularly moisture, where clay readily absorbs and desorbs moisture. And so especially in these affordable housing schemes where you have relatively small room sizes and can have problems with ventilation, this regulates moisture effectively between 40 and 60%, which is the kind of the optimum level for human health. And these kids, they had asthma in the previous house they lived in, and when they moved in here, they stopped having asthma attacks. And in fact, in the bathroom, the monitors told us that you didn't need to have an extract fan because the walls absorb the ambient moisture from showers quicker than it could be exhausted by a mechanical fan. So moving on from blocks, we are going to look at mud wall, which is known in other places than Scotland as cob, but we call it mud wall. So that's, I don't know what the proper term for Rowland is now, but so this is a community building we built, and you can see it's a kind of an S-shaped thing laid out on the ground. And here this was an interesting way of mixing it. We dug a hole in the ground and we used the clay subsoil just mixed with straw in the ground with the digger. So it was a very lean process for creating our mix. And then the tractor took it away to site, which was about a mile away. And so in this case, we're building mud wall off a stone plinth with earth mortar on a gravel trench foundation. And then we sort of corralled various local people and children and so on to build the building up, which you do in layers about 2 foot high. And then we had a nice opening. This is a park shelter, really, for a park. It didn't have a shelter in an area of traditional clay construction. And you can see in the background, the horizontal lines of the lifts of the cob construction, and then the plaster that we made for part of the areas. And of course, it's very benign and animal friendly material. And you can get a really nice range of textural effects here. You can see the lines here are created by the surface being beaten by a fork, which is the traditional technique of finishing earth. Okay, so I'm going to crack on. And the roof here was a core 10 roof on a kind of a complex double curve thing, but it all worked quite well. And the kind of, I just wanted to show the kind of stretch then from the 17th century thing right through to current innovation. And Rowland's touched on this composite wall between a traditional cob wall and the light earth, bringing them together in open mesh formwork to increase the speed of construction and the rate of drying, which is part of a collaborative research project. And this is a prototype building going up in Plymouth with some experimental renders. And we've got a great international team that are working on this. And, oh, right, okay, I forgot about this one. So this is the final thing. I'll just rattle through this. So plasters. So a lot of our projects, we plaster them, but it's really hard to get nice pictures of internal plaster. So I'm showing you some outside plaster. And this was a project at the Chelsea Flower Show a couple of years ago, where we made these curvilinear walls rendered with earth plaster, and which was kind of a multi-layered thing, and it should have taken 5 weeks, and we did it in 5 days, and it was a bit crazy, but we ended up having a nice sort of textured finish. It was kind of inspired by a sand dune. So it was kind of trying to imitate a sand dune in clay plaster. And it included the technique of sgraffito, of carving through different layers of coloured clay plaster to achieve a decorative effect. And that is the end of my presentation. I should just say, if you want more information about the Caboge project, there is a website and you can sign up there for more information. And then we'll be running some training events next year on the internet, and you can sign up to participate in some of those. Thank you very much.
Thank you so much, Tom. That was really, really lovely to hear that side of your experience of building in so many different ways. We are shortly going to just move on to Becky, but in the meantime, there are loads of questions coming in the chat box, which is brilliant. I can see we've got nearly 200 people on the call at the moment, which is fantastic. Yeah, please do keep asking questions, and also the speakers, if you want to answer any of them during the conversation, that would be great, because I don't think we'll get through them all at the end. So we're now going to move on to Becky. So Becky, do you want to introduce yourself, and then I'll share your video?
Okay, are we on?
I think so, yes.
Just very briefly to say, this is the bit where I'd love to be in the room with you, and we'd all get our hands in a bucket of soil. So I've basically put a video on of me with a bucket of soil, and I invite you to join me in touching, smelling, maybe even tasting that soil. That's all I need to say, and we're just going to get down in the earth.
Excellent, thank you. I will share my screen now. Hopefully you can all see that. Can I get a thumbs up from somebody? Yeah, great. Okay, let's play that.
I have some subsoil. So we've removed the top layer, the topsoil, and this is the more mineral component of the soil below. And what we want to know is what's in it and whether it's going to be any good for building. And I can feel grit, gravel, and I imagine there'll be plenty of silt and probably clay too. So that's all we can tell at the moment, especially with a dry sample like this. So we don't really know yet if it's going to work for building. Although if we were in an area with traditional historic buildings made of earth, then we suspect that it could be a good soil. That would be a good indicator. So if we want to get stuck into this a bit more, we can make it wet. Just in true Blue Peter fashion, I have one already prepared. So here's the exact same soil with some water in it to make it plastic, a bit like modelling clay. And so I can start to, I'm going to get a bit more water actually, so I want enough water to just make it soft and movable. And most kinds of earth building involve moulding and shaping and compressing the soil with some water present. So I have a sense now that I've started squishing it, that there is some clay present. The clay is what creates the glue and gives it a bit of stickiness. And so the fact that I can just make that ball suggests there is some clay. Another way I can find this out is I can take a clean knife and draw it across the surface, and clay will create shine. And the shinier the surface where I've drawn the knife, I don't know if you get a sense of that, maybe I'll move it around, the more clay is present. So
on their own, none of these tests tell us enough, but together you'll see we can get a sense of what we've got. Now, something I always do, but it's not very scientific, is you can see there as I squish this ball, the cracking. And the cracking is an indicator that it's not that clay rich.
So although there's some clay there, it's not completely bound the materials together. And I often try and make little pots. So everyone has their own way of knowing how to work out what's present and whether it's going to be any use in a building technique. So at the moment I'm thinking, okay, it's got a bit of potential. I can shape things with it. One way I can check, another way for checking for clay is how easy it is to wash my hands. So I know that if this stuff comes off quite easily, then the chances are it's not, and it is coming off pretty easily. It's not very much clay there. Let me show you a different sample for a contrast. Here's another one. So that one was in the field nearby. I had to dig a hole. Here's one from Perthshire in a big area of flatland called the Castle of Garry. Now this is a completely different beast. It's got a greenish brown. The colours don't matter. Clay soil or subsoils can come in all colours for building. But it's much, much shinier even just without pushing the knife across it. It's got a lot of shine. It's very sticky. And I know that I'll be washing my hands for 5 minutes to get this one off. And in terms of shaping, I mean, this, you could definitely make pots with this. It's not cracking at all. I mean, it's a bit wetter, but it's really malleable, and there's no coarse aggregate at all. In fact, I can really not feel anything in there. Maybe the odd tiny bit of sand. One way to check, if I'm not sure whether it's silt or clay, that's the fines, because those are so small I can't tell by eye. I could actually put this in between my teeth. And I don't recommend doing this, but if you want to know, the teeth can tell when silt's there, but you can't feel clay. Clay is so small that your teeth just can't recognize it, but the silt you can. Just to show the point about the clay, it's when there's lots of clay present in a soil, it's like soap in your hands. It feels like soap, and it really does take quite a bit of getting off, because it wants to stick to you as well as everything else. So another test we can do is making a sort of long, the French call these cigars, I call them sausages, but we make a long cylinder with the damp, sticky soil, and then we want to pass them over the edge of a table, or your hand will do actually. So basically what we're looking for is where the cylinder breaks. So basically, here it is. And you can do this multiple times to check that you get the same results. And then when you've done it several times over and you start to collect lots of these things, and here's one that's been sitting in the shed. So that's, those will be where the cylinder broke. And here's another one. And you start to see a pattern with each different soil. At what point these cylinders or sausages are breaking. And actually this is a really good indicator of clay content. And the strange thing is, and I've got a ruler here, the length of where these things break is often a really good indicator of how much clay is in the soil. So 9 centimetres and 8 centimetres. And probably if I'd done that lots of times, I'd find an average. And so I would guess that there's something like 7 or 8% clay in this soil here. And this one, about 14, 12. So, probably roughly 13% clay. Now, it doesn't work every time. I wish it did, but it's often very close to that. If we get a lab test, it backs it up. The times when it fails, and I'm going to go back to the really sticky one, is when you have this kind of soil, which is incredibly fine. I know that this soil has got plenty clay in it, but it's also predominantly silt, and that can sort of exaggerate the results. So I suspect, this will probably break at about 40 centimetres or something like that, and it might be more than the clay that's in there. So the next test I want to look at is a shrinkage test. So we take the plastic damp soil and we squash it into a mould. It's a wooden box, square section, and it's 50 centimetres long. And once this damp clay dries, I can measure off how much it shrinks. And in this case, I've written it down as 8.2% shrinkage. Now, in building terms, that's problematic, and lots of clay in a soil usually does mean quite a lot of shrinkage. Although again, grading of the different particle sizes really can make a difference. But there are lots of things I can do with a soil that's quite got large shrinkage like this. And I'll show you in a minute one of the things I can do, but this is a great place to start. And this is kind of my most useful test of all, if anything. So 8.2% tells me that it's probably, again, clay rich. But what I can do with a clay rich soil, and this was done to some degree in the past, we think, but in fact, in some ways, it's more of a modern practice, is to optimize mixes. Here I have, this is a mortar. So I can take a clay rich soil, I can mix it with aggregate, that's sand, grit, depending on the place I'm working. And I can also mix it with short chopped fibre. And I know that that will reduce and manage shrinkage. So here I've got 1 part clay to 3 parts coarse sharp sand. And the shrinkage has gone down from 8.2% probably to closer to between 1 and 2%. And that's the kind of shrinkage I can deal with in building. So that's one way of changing the soil. But of course, you might be lucky and you might find a soil that is just perfectly balanced and good to go. And in traditional times, very often fibre was used to create some sort of balance, depending on what you were working with. And just one last idea for a soil test, which is very simple and you can do out on the site, is to take a little ring, a piece of pipe. It can be a bit bigger than this, but this is quite small and handy. And cut a small section off, and then take your damp soil and squash it into this. Use it like a mold. And then when it's nice and flat and full, make sure you can level it off with something, like a ruler, and then you leave this to dry. So here we have some of those little biscuits that are already dry. Here's the one that you saw before. It's a bit rough because it's got stones in it. So one thing you can do, which I didn't mention, is you can remove any of the larger stones before you make the little round shape. And then we get a sense of shrinkage actually even from these little bits of pipe, because you can see here quite a large amount of shrinkage in that sample, and this red one much less so. And I know even from this incredibly small test that this soil with, you know, probably quite a low percentage of shrinkage is going to be easier to work with as long as it's got enough clay in it and it's sticky enough. So I can now break these and I get a sense of how strong they are. So for sure there's clay in there. It took a little bit of effort to break. I'll work my way through. Here's the one that was the shrinkage was very high. Yeah, that you can see there's a little inclusion in there, but that was much more difficult to break than the dark one. Now the red one. Yeah, similar again. Difficult to break, took some effort. And finally, this last one. And that one, actually, I don't think I can break it. No. So, I mean, I know from my own range of soils that I have here, this is the one that is very rich in clay. And I literally can't snap it. So.
Excellent. That was a really good video. Thank you, Becky, for that. Really felt like we were there with you with our hands in the clay. I loved seeing it from that perspective. It was great. Brilliant. We're now going to then move on to Paul next, Paul Mallion. So I shall ask you to unmute yourself, Paul, and we'll hand straight over to you if you can share your screen.
Thank you very much. So I'm going to do a series of case studies on earth buildings that we've worked on over the last 15 or so years. Here we go. Hopefully that's clear to everybody. I'm a chartered building surveyor and a certified Passivhaus mentalist. And I try and combine natural materials with Passivhaus to avoid using too much plastic and foam and everything that seems to be very popular with the early uptake of Passivhaus. I think now that we know more about Passivhaus, we can use natural materials. So the first case study I've got is a community and conference centre in Dover in the southeast of England, which is constructed from rammed chalk. So we were very lucky being in Dover on the White Cliffs. Our site is pretty much built on chalk. So it was really easy for us to find chalk to work on. And the whole idea of using chalk for this building was just a joke that the engineer made at an early design meeting. But I took him seriously. So I did some research and found that rammed chalk was quite common in Dorset in the south of England. It was almost unknown in Kent, where the project is based. So we started off looking at using chalk from a conservation point of view, and we found out how it was done in the past, manually breaking up chalk using these hardwood oak tipped ramming tools, and we created our first chalk wall down here, which is very rudimentary and a little bit too primitive. But we weren't put off, and we took a concrete testing cube, rammed a sample and took it to Canterbury College. And they hadn't used their concrete testing kit for about 30 years, but it still worked. And we got a strength of about 0.5 Newton per square millimetre, which isn't very strong, but it turned out to be adequate. So we carried on doing our tests with, this is Rob Buckley from the Dorset Centre for Rural Skills, who taught us how to do rammed chalk the old-fashioned way. And as we did our little tests, they got better and better until we created this metre-long sample. And our engineer came down from London, and he wasn't really convinced, you know, having made a joke about using chalk, he wasn't really convinced it would work. But he picked up a hammer and gave this sample a whack. And in that instant, we knew he was on board, because it almost rang like hitting a piece of stone. We'd done this sample so beautifully. So that convinced us we could go ahead and use chalk for this building. And Rowland Keable was on our team and came on board as one of our earth consultants. And he was working with Bath University, Dr. Peter Walker. So we sent a few tons of soil down to the university to be tested. And on the left, there's our chalk, and on the right is someone else's clay sample, rammed clay. And these were then tested in a number of different ways, using columns, shear testing, compression testing. And the results from the testing showed that my little cube wasn't far off. So we got results of between 0.48 and 0.64 newtons per square millimetre with the testing. And our engineer was able to put that into the calculations to work out how thick our walls would need to be to support the 2-storey building and the loads that we were going to put on it. And because the material was free, we could have the walls as thick as we wanted. So in this instance, we ended up with walls 650 millimetres wide. Now in the UK, you can't have a rammed earth wall on its own. You need insulation. So we put all the insulation on the exterior, but left it as a raw finish on the inside. Once we started construction, we were building in a slope. So we were able to cut away the landscape to create a flat surface for our building to be based on. And we've completely isolated the building from the ground on a layer of foamed glass insulation. And you can see up on the top left, we're storing our chalk up here, keeping it dry, because the chalk is quite sensitive to moisture content and it needs to be as dry as possible for ramming. Now, this is where Rowland took over as building contractor for the rammed chalk stage, and we used heavy-duty steel reusable shuttering. We used a skid loader down at the bottom right here to crush the chalk into small enough particles, place it in the shutters, and the team of contractors then used a pneumatic rammer. And this accelerated the process from like 1 cubic meter a day to something like 18 cubic meters a day, or a length of 6 linear meters, 3 meters high in a couple of days. It's a really fast construction process. And the finished building, this is the interior. You can see the rammed chalk and the strata in the background. We also trialed here Guastavino timbral vaulting, which is a Spanish technique, and that's worthy of a little discussion on its own. This is one of the main halls in the building with the timbral vaulted roof dome, and the external solid walls are all chalk, and then these large openings here where we've got concrete columns. Then this is the building on the exterior. We designed this building using the Passivhaus principles. They weren't actually published in English at that time. So we used all of the principles, we translated them. It's got a mechanical ventilation with heat recovery system. We couldn't buy triple glazing in the UK, it had to be imported direct from Germany. But it is a very successful community building. So from there, we went on to do a teaching block for a college, an agricultural college in Sussex in 2007. And here the soil was completely different. It was clay. In the summertime, when we were exploring this idea, the clay was so hard, it was almost impossible to extract it from the ground. But we managed to do a very rudimentary test with some reusable steel shuttering and mixed the clay with aggregate and came up with our first little test panel. It's not a beautiful color. There's a bit of rust on it from the shuttering, but it was really hard and strong, and it gave us the confidence to move on to the next stage. We put in a funding bid and we won funding to construct this teaching block, and we were then able, with Rowland's help, to do a teaching course with the contractors that had won the contract to construct the building. And here we've got the contractors in a barn at the agricultural college. We've got a timber shutter, and we used some clay obtained from site mixed with aggregate. But by the time the funding came through for the project to start properly, the British summertime had finished and we'd had 6 months of non-stop rain. So the clay soil had gone from being too dry to dig from the ground to being far too wet to use. But thankfully, through Rowland's contacts, we managed to get a donation from Ibstock, who's a large British brick manufacturer. They donated us several tons of powdered dry clay that we were able to use with our locally obtained aggregate to use in our test panels. And then we went on to use that dried clay for the teaching blocks. So this has a slightly nicer finish. It's better textured, better quality shuttering. And that gave us the confidence to use this mix for the project. So in this instance, we came up with a prototype foundation where we had a simple concrete strip foundation and a block wall, but we used a staggered ultra low conductivity block where the outer projection of the concrete block supports the insulation and the inner would support the floor structure. And the reusable steel shuttering, as you can see on the left, is resting on those projecting parts of the blockwork. And on the right and the bottom right, you can see the reusable steel shuttering being released after the earth has been cast. Now, this particular mix of earth with aggregate was 3 times stronger than the chalk. It was 3.1 newtons per square millimeter. So we were able to design this wall down to 265 millimeters. We thought we were being clever by having a thin wall and being very efficient with our material, but actually it was too thin for the workers to stand inside the shutter to do the shuttering. So they had to lean over the shuttering and put the ramming tool down into the shutter. For subsequent projects, we've made the shutter at least 30 centimeters or 300 millimeters wide, so that a pair of size 12 sight boots can get inside the shutter and work much more easily. We used timber lintels for this particular project, with a careful bit of damp-proof membrane around them. And on the right-hand side, you can see the window opening where we've lined the window with plywood to give us a precise opening for each of the windows. For thermal insulation, we made up prefabricated timber panels, which we filled with 150 millimeters of sheep's wool. At the bottom, you can see the window lining, the plywood lining. And internally, we used clay plasters and clay paint. So the whole building was as natural as possible. Here's an internal view very near completion where the earth is drying out. We used plywood to make protective barriers against damage from chairs, because these are all classrooms. But you can see at the right-hand side of that trunking that the plywood has sucked out moisture from the walls. So even though they look dry, we had to then put a little damp-proof membrane in there just to prevent any damage to the plywood. And this is the finished building. It was very simple, low cost. They had solar thermal, biomass district heating, sedum roof, rainwater harvesting, and the whole site has a reed bed sewage treatment system. So this was done for a college, but the local authority, East Sussex, loved this project and they wanted to go further and do more of them at other secondary schools around the county. So we had a great team, an engineer, contractor, and East Sussex County Council thought the best thing to do the next batch of classrooms was to appoint a completely different team of people who knew nothing about rammed earth at all. So after many months of persuasion, they finally agreed to let us come on board and help them design the next raft of classrooms across the borough. And we teamed up with a local architect, and Rowland, Keable and I helped do some training on site. So these batch of classrooms are built around the East Sussex with this heavy-duty reusable shuttering. And what I particularly like about this system is that you can have your handrail and support bracketry here for working in a safe situation. That they would put handrails through on these projecting brackets so that the workers were safe from falling. But in this particular instance, there was a bit of a disconnect between myself and Rowland and the building contractors, because we weren't in a direct contractual link with the contractors, and they didn't listen to our advice very often. So we did have a few problems. We had a nice big crack appear here on one of the corners, but we were able to repair that and overcome these issues. Here you can see the interior of the classroom in the drying out process. And we tried to make the buildings as airtight and efficient as possible so the earth can do its work. Here's a close-up of the earth on the left. Externally, we used very lightweight, quite widely spaced eye joists to create an insulation zone. We put a breather membrane between the insulation and the earth so that the moisture wouldn't affect the insulation during the drying out process. And then it was clad with another layer of breather membrane and then timber boarding. So this is the interior a little bit further. You can see these particular classrooms are quite highly serviced. There's a lot of mechanical and electrical services going in. And this is just near completion. We wanted to mechanically ventilate these buildings because classrooms need high levels of air movement. But the architects decided to go with a passive ventilation system. I don't know how successful that's been, but typically natural or passive ventilation systems don't really work very well on single-story buildings, particularly in classrooms. So we then moved on to doing a fully certified Passivhaus in Canterbury in Kent for a very successful artist. And we wanted to do a quick, lightweight timber frame building. This particular artist creates huge works of art, which can be 4 meters long and 2.5 meters high. So we almost needed to create a warehouse for him. So we teamed up with an engineer and came up with this idea of creating a portal frame using eye joists. So there's no tie beams and no thermal bridges for many tie beams from side to side. We created the space for the ram chalk wall. And then we decided we would put ram chalk in the middle of the building to act as a thermal mass to stabilize any temperature swings. So we're able to erect the shuttering in a nice, clean, dry environment. We bought agricultural grade chalk from about 10 miles away, which was nicely processed, very evenly graded. And this is the ram chalk wall just after the shuttering has been struck. You can see it's very crisp and white, very pure. The contractor on this has done a few projects with us and really understood the methodology. And one thing to remember if you are using rammed earth, just like with a polished concrete floor, you create the finished article very early in the construction process, so then you have to protect it, which is an added cost to bear in mind. So this is getting closer to completion. And that is a fully certified Passivhaus, the first industrial Passivhaus in the UK. And this is the exterior, which is finished with finger jointed sweet chestnut from the Kent woodlands. Next, we did another Passivhaus in Faversham in Kent, where our soil analysis showed that we had clay and chalk on site. It was quite a big, long, skinny site. So we did some testing and we realized, this is hard work doing rammed earth. So keep your builders nicely fed with biscuits and donuts. With Rowland's help, we ran a first little test on our samples of chalk that the client dug from site themselves, brought to a warehouse, and we did a test. It wasn't a beautiful sample, but again, it gave us the confidence that we could use this method. And again, we wanted to use the chalk as a thermal mass wall inside a timber framed building. So once the timber frame was sufficiently advanced, we were able to start doing some on-site tests with the chalk. And this is natural chalk straight from the site. Faversham in Kent is well known for its brickworks. So there's a lot of clay on top of the chalk. So this chalk is much more natural in colour, much warmer colour and texture. But you can see this is a much nicer quality sample and was used as the example to carry on for the next stage of work. So here on the left, you can see the shuttering has been struck. We've got the nice clean face. The top right is the shuttering under construction. So we completely constructed one side of the shuttering and left the front face exposed and raised the shutter in stages as the work progressed. You can also see the ventilation ducts and things going into the timber frame. On the lower image, we had an L-shaped wall and we created a lovely internal corner. And I think this particular chalk has a sort of travertine marble effect, which is really lovely. So this is the finished article. On the left, during construction, drying out, and on the right, the completed building. And we wanted this chalk to be able to absorb heat from the sun from our large south-facing windows, which from our modelling showed that we could reduce the amount of solar shading that we needed to use. And my last example is another education building where we used Hempcrete and rammed earth. Again, the rammed earth was to be a thermal mass because the Hempcrete is much lighter and has good thermal properties. The beauty of Hempcrete is that it's almost a monolithic structure. So you have a very light timber frame, you cast the Hempcrete around the timber frame, and then you simply plaster the inside and the outside. So compared to timber frame construction, where you've got multiple layers of vapor barriers and breather membranes, it's remarkably simple. But the one thing to bear in mind, especially if it's a commercial project where you have a fixed completion time, is that Hempcrete takes a very long time to dry out. And we grossly underestimated the drying out time for this particular building. So here you can see in the bottom right is the rammed earth wall. At the top right is the rendered Hempcrete. We've got a south-facing atrium to bring sunlight in. And the idea is that the atrium shines light onto the rammed earth wall, which can absorb the heat and store it. All the other windows are north lights. And this is the rammed earth wall. We were able to introduce full mechanical ventilation with heat recovery to this particular classroom in conjunction with natural floor finishes, clay paints. So we have a lovely, healthy interior and with really good air quality. And we're now doing a lot of work on other schools trying to improve air quality because it's a major problem in schools, especially since COVID has become a major factor. So that's my last slide. Hopefully we got through that in reasonable time. And thank you very much.
Thank you, Paul. That was really really inspiring to see rammed chalk and rammed earth being used in so many different types of modern new build construction. We are running just a few minutes behind, but not doing too badly, but we're going to move swiftly on to Claire now, who is going to talk to us about clay plasters. So over to you, Claire.
Hello, everybody. Just trying to share my screen. Can you see my screen?
Yeah, we can see.
Okay, just trying to get it onto oh God, I can't get to it now.
Should we try just going through it like this, and we can see the slides pretty large anyway?
Okay. So my objective is to speak to you about clay plasters, what they are, how we're trying to make them accessible, and how we can enable architects to specify clay plasters more easily. So our background, the company was founded by Adam Wiseman and Katie Bryce, and they started off by by digging up clay on site, as we've been speaking about today, and they were digging clay on site and putting it on small buildings. They were very committed to natural building and building these natural sort of cob buildings. And they realized the potential for clay plaster, realized the sort of the beauty and all of the aesthetic potential and the performance potential of clay, and digging it up on site, and was very close to our hearts. But we realized that we couldn't make clay plaster accessible to everybody by doing it this way. So back in around 2002, the focus became on how we could make clay plaster more accessible to everybody. And so began in around 2002 a long process of research and development into how to make clay available to anybody, anywhere in the world. Clay is a very simple material. It's a natural. It's just natural clays and minerals and sands and all very simple ingredients. But actually getting it right is really difficult. So our founders traveled around the world and wrote 2 books, and they studied cob building and natural building all around the world to research clay plasters, and wrote 2 books along the way, and basically researched and tested thousands and thousands of different clays, different formulas, different mixes to make it available. In 2010, eventually we released our own clay plasters. And these were dried, ready to mix, and ready pigmented. So clay plasters are now our clay plasters, and there are various other clay plasters around the world. Clay plasters come in a dried powdered form like this. Some are pre-pigmented, some are not. Ours are. So they're very accessible, very easy to use. They're dried. They're all 100% natural materials. They come in these bags, and all that needs to be done is to be mixed with water and applied to walls, ceilings, other surfaces with traditional plastering tools and plastering skills. So we sort of felt like we'd really made them accessible, and we were really keen to get them into the market, to take them to places where it couldn't be dug up on site in urban environments, and we launched into the market and started doing a lot of sort of natural build houses. We reached into that sort of natural build world, the natural materials. And we didn't actually really gain a lot of traction at that time. This was around 2010. And then we were discovered by Nando's restaurants, and they started to use our clay plasters for restaurant finishes. And that sort of catapulted us into the design world, into the architectural and design world. And we suddenly realized that actually what people loved about the clay plasters was the aesthetics. And we were pushing on the fact that clay plasters were sustainable, they were healthy, they had all of these benefits, but people were buying them because they were beautiful. And we realized we had to really sort of change the narrative. And we needed to rebrand, and we needed to push these sort of natural building materials, the 100% natural. We needed to push them on the aesthetic benefits. So it was it's a great irony to sort of read the statement in Dezeen just last week, to say that actually aesthetics are still valued more than sustainable design. This was an article where I think ACAN and Scott had an input. And it's still shocking to see that there's this trade-off between sustainability and design in the architectural world, because the great irony is that we found the opposite. For 10 years, people bought our clay plasters because of the way they looked. And I think I can safely say that for sort of 10 years, till about 1920, till 2020, people just weren't interested in the sustainability side of them, or the health side of them. And so we really focused during that time on building the aesthetics, on really refining the product. We tried to sort of get away from this idea that Tom and Rowland really alluded to, that there's this perception of clay plasters, of earth building materials, as kind of rural, as primitive. Clay plasters are possibly one of the most ancient of building materials, and yet they're actually a very beautiful modern material. So we tried to bring it into the contemporary design world. So we really focused on the aesthetics of clay plasters, of really fine-tuning them. We brought in a lot of color, and we tried to get away from the idea that clay is limited to earth colors. We researched mineral pigments from around the world, and tried to introduce a lot of different colors, and try to make it clear that you can introduce a lot of different colors. So clay plasters aren't just this kind of soily, earthy look. We can actually make them now so many different colors, so many different textures. And it's also true to say that I think there's interestingly, the poll tonight showed a lack of knowledge of earthen materials as the biggest barrier to sort of mainstream acceptance, which is something we've really been trying to focus on. And in terms of trying to make it more accessible, we've been trying to get out this message that actually clay plasters can go on to pretty much any substrate. And again, over the last 10 years, the most typical wall build-up has just been onto a gypsum backing board. Not a natural material, of course. We can't get involved in the specification of the backing board, but actually a clay plaster can go straight on to a gypsum backing board. It's really simple. It just needs to be scrimmed and repaired. And then there's a primer, a key put on, and then the clay plaster, and then just a glaze. Clay plasters, our clay plasters are all naturally pigmented. They'll never need painting. So either at any time of their life, the pigments are mineral, so they are UV resistant, they don't fade. When we come to other surfaces, obviously we're really sort of pushing wood fibre and clay panels. Obviously, clay is a natural bedfellow for straw and straw panels and all of these sorts of things. It is normally the case that you'll need a backing coat of clay. So it becomes a two-step process where you put on a backing coat, then the top coat. So it's really easy. It can go on to pretty much any substrate, including all sort of typical modern substrates. So really easy to use. It comes out of a bag and you plaster it with normal plastering tools and skills. I think one of the key things about clay plasters, and one of the biggest things that the people we talked to didn't understand before we spoke to them, is that when clay, this mix of dried raw materials, goes onto a wall, and as it dries, it doesn't cure, it doesn't set. So unlike say a lime or paint, or gypsum, varnish, anything like that, clay doesn't set. It maintains this rawness. It's a raw material, and that gives it this very unique aesthetic. and you can literally sort of scrape it off the wall, and it would still be that raw soil, that raw earth that everybody's spoken about tonight. So it has this very sort of unique aesthetic, and it's also very fundamental to all of the other performance benefits. So it's great for architecture, it's great for design, it can be used on all walls, ceilings. It comes in every single color. Clay plasters can be layered. You can fade the colors, or all of these sorts of things. The aesthetics are sort of limitless, and hence we're often asked to sort of mimic or recreate the effects of many other sort of common building materials, such as travertine, rammed earth. Of course, we talked a lot about rammed earth today. It's a fantastic building material. It's not always practical in the middle of a city centre, but in terms of sort of that look, that aesthetic, that raw earthy aesthetic that people want, you can create that with a clay plaster, because of course it is a raw earth. And you can also create these other sorts of sort of monolithic sandstone-y looks. So this is just a 10mm thick clay plaster on a backing board in a restaurant in London. So it can solve a lot of these problems of the aesthetics that people are trying to achieve, where maybe the actual raw material is not practical. It's also used all the time in everyday renovations. For the sort of the finishes that I've just been describing, you would need a good plasterer, but we used clay plasters are used in DIY projects and home renovations all over the place. And we're constantly sort of following these great stories of people just sort of getting the hands in the mud, as Becky said, and putting it on the walls. So it's very accessible now. It also solves a lot of other problems. So whether we like it or not, the concrete aesthetic remains really, really popular. A lot of people want that sort of concrete aesthetic. We can create sort of shuttered concrete looks, smooth concrete, polished concrete, and this sort of raw concrete look. So for this sort of big building, concrete, as we know, is a huge problem for carbon. It's potentially responsible for about 8% of carbon emissions in the world. And actually, you can create that sort of look with literally with say straw panels with clay on the top. And clay being a circular material, it's called a circular material because it's extracted, and when it's manufactured, we're literally mixing those raw materials and then shipped aside, put on the walls. And at the end of life, it can, in theory, just go straight back into the land on site. It doesn't need to be taken away in a skip or disposed of in any sort of special way. We put no additives in our clay plasters. There's no polymers, no additives, nothing. It's literally sort of borrowed from the land. So all of those aesthetics can be created with naturally pigmented clay plaster. Because of the lack of processing and additives and disposal problems, we actually save huge amounts of carbon. There's not enough time to go into it today, but there have been calculations done by such as the Materials Council, where they've proved that you can save up to 2.4 kilograms of carbon if you use a clay plaster rather than a gypsum and paint wall build-up. And one of the reasons for that is that the paint has a very, very high carbon footprint, all the processing, all of the materials, all of the packaging, disposal issues, waste issues, that sort of thing. So, so clay plasters have a very low carbon footprint, and I always refer to this graph by a sustainable building consultancy, John Butler, who may be in the audience. So John Butler benchmarked all of these building materials, and this is the carbon footprint of all building materials. Wood, of course, is optimum because it sequesters carbon, and clay. This is a sort of a close-up of that diagram. Clay plaster has very little carbon footprint, just because of its simplicity. So very carbon friendly.
Just going to give you another minute or two, and then we're going to have to wrap up. So
yeah, no worries. So this is just a quick sort of case study of sorts of looks, and clay is also very healthy. It's breathable, and it absorbs moisture. It's got no bad materials. So how do we try to enable architects to use clay plasters? Well, we've had to provide a lot of sort of verification, a lot of certification. It's all very well for us to say these sorts of things. We've had to prove that they don't give off VOCs, that they don't emit gases, that they have thermal value. We've provided the data. We've provided the acoustic data, the light reflective value data, and we've even produced an environmental product declaration. We're very proud that we're the first company, first clay plaster company in the world to provide an environmental product declaration. Also fire certificates, all of that sort of thing, and we're trying to sort of really share the knowledge of where clay can be used, where it can't be used, and trying to reach out to architects who are under a lot of pressure right now to provide the right materials and specify the right materials. So so we're on a real sort of mission to show how they can do that. So yeah, lots of case studies. Sorry, I've shot through this. I know that we're against the time, but loads more information, and always happy to sort of talk to people about clay plasters.
Thank you so much, Claire. That was a whistle-stop tour, really, but it's brilliant to see how easy it is to use clay plaster in pretty much any project, and I hope a lot more people will start using it after this event. We have just a few minutes left now for question and answers, so it's going to be a little bit condensed, but we're going to try and just fit in a couple of questions to the panelists. So have we got the panelists spotlighted? Is that happened? Okay, we're going to start with a question. Well, a few people have asked questions about durability and maintenance. So we've got some questions. How physically durable is clay plaster? Does it scrape off? And what, it's just popped away. Sorry, what maintenance is required for earth buildings and clay plasters? Would anybody like to jump on that? Any of you speakers like to answer that first?
Do you want me to do that since it was clay plasters? That's always the question that we're asked, and I think the answer to that is that clay plasters, as a raw material, we have to respect the material. It likes to do what it does best, which is breathe and sort of clean the air and look beautiful and with moisture. It is pretty durable, but it doesn't like running water. It can't be used outside. It can't be used in wet rooms. and it doesn't like being sort of bashed around. It does have the same sort of impact test actually as gypsum, but yes, if it's constantly subject to bashing around or brushing, it will tend to sort of wear away. It is easily repaired. Being through pigmented, you can scrape it back. You can just put another layer of plaster on.
That's really helpful. Just you touched on it being used in bathrooms there. I just wonder if anybody wants to mention Tadalac at all, or if that's another topic in itself. But Becky, you've worked on some Tadalac as well, haven't you?
Actually, I haven't done Tadalac.
Sorry, I thought.
Yeah, no, I've done various clay finishes with oil. But you can make sinks and you know, kitchen surfaces and showers and but you'll need to put some sort of sealant on them. And of course, we don't recommend using sealant over big areas because then you lose the breathability. But Tadalac is, yeah, it's maybe somebody else here will probably have done it, but it's another way of using these. It's a lime-based material. So.
I'd like to just sort of bring it back to Tom's point, which was that the bathrooms that they did in the housing scheme that he showed perform extremely well in a bathroom situation. You don't have the water from the shower running down the wall, okay, but otherwise having clay in a bathroom is not a problem, or a kitchen is not a problem, and actually having it there improves the air quality, the humidity, all of those kind of things, because that is what clay is very, very good at, is managing humidity in the air. So in those places where there's a lot of humidity, like bathrooms and kitchens, absolutely you use it. Just, you know, just
it reduces condensation, both because it's absorbing the ambient moisture and also because it has a warm surface. So you don't get as much condensation in an earth plastered room as you would with a gypsum plastered room.
Can any of you talk on how you would repair an earth, either a rammed earth wall or a clay plaster? If there's, for example, a damage done by removing fixings, how would you go about repairing that?
Well, I mean, as a general rule, because I repair old buildings, you take the old material, you soak it and you put it back.
Excellent.
That's kind of it, really.
And the issue for round earth, for instance, is that people have become quite obsessed about the off-form finish, the way that it looks when you take the formwork away. It's very difficult to get back to that if it gets really badly damaged. Whereas with a plaster, what you're looking for is a tooled finish. So you wet it up, you put it back on again, you tool it off. There you go. And that's pretty much the same for, you know, for mass earth finishes, and so yeah, it's just this thing about an off-form finish with round earth, which is quite difficult to get back to.
It talks to this fundamental point about all earth materials, that they're not changed in a chemical way by the application of energy, and they're not changed. They don't. They're modified by their relationship to water. So in all ways, they're made in damp form, and that creates the shape, whether it's a pre-made thing like a block, or whether it's a wet applied material like plaster, and they become solid by drying out. So this thing of wetting and drying is fundamental to earth materials, and why they're low energy, and why they're fundamentally recyclable, why they're a low waste material, and why they're easily repairable, because you're not applying any chemistry to it, and you're not applying a state change by increasing the temperature. And so the relationship to water is the fundamental thing about clay-bound materials that's different from cement or ceramic materials.
It's a really nice sum up of the...
There's a really good example, am I unmuted? There's a really good example of damage to rammed earth buildings at the Eden project in Cornwall, which Rowland did. where the rammed earth is external, and 1 million visitors a year stick their finger in it to see what it's made from, and it's still there. It's survived.
Just a quick question for you, Paul, actually, is how long, you mentioned about how the rammed earth walls drying out, how long roughly did they take to dry out?
Each is very different. At the Pines Calyx, which is the circular chalk building, there are a lot of spaces with no windows, deeply recessed within the plan. And we had air movement fans going to move the air around. It was probably in the region of 6 months drying time, but that coincided with other works carrying on. It was a 2-year building contract. We actually probably had more problems with the Hempcrete building drying out, partly because that was perhaps a little bit less well understood. And the fibres tend to hold on to the moisture for a very long time. But as we progressed and we learnt more, we just made sure that we put the earth structures in a situation and at a time in the contract where they would have plenty of time to dry. We'd make sure that the buildings are well ventilated with air movement fans, and it didn't really seem to cause a problem in the later projects. But then in later projects, we're quite often using it just as a feature wall or as a thermal mass element in a building and not the whole structure. So it was less, not on the critical path.
I think it's worth saying also that there's been quite a lot of reference to this word clay as though it was a thing. But in fact, clays vary quite a lot. So you've got kaolin, kind of fine china clay, and then all the way through to bentonite, and they absorb different amounts of moisture. They expand and contract differently. Becky showed you the little discs that she was making. Some of them break more easily. Some of them she couldn't break. So clay is not a completely unitary thing, and so this gives you different response times for how much moisture you put in it to begin with, and how it loses it over time. And then Paul's also talked about calyx, which was chalk, which has no clay in it at all, and actually holds a lot more moisture than a clay wall, and therefore takes a lot longer to dry out. So it's one of these tricky things about natural materials, that they don't they don't just do one thing, and whether you're building in August or January also has quite a big result.
Thank you. That's a really nice set of answers to those durability questions. There are loads of other questions that have come in, but unfortunately we've already run over our time. I just want to thank everybody for coming, all the speakers, obviously. Thank you so much for your time. Thank you everyone also for attending. We have recorded the event, and we will be sharing the recording with you all. It will be available on the ACAN YouTube channel for free for anyone to watch. We'll email around all the attendees an email in the next couple of days with some follow-ups, some further reading suggestions, and if we can get the video up in time, we'll add that link in with that email, so you should all get that very soon. Unfortunately, I think we have to leave it there, although I could go on talking about this all night, but we will be having many more events, including ones on Hempcrete that briefly was mentioned, and lime as well, and other things coming up, so keep an eye out. And we've also got a survey that we've been doing as a group, and we're going to post a link to that at the moment, just in the chat box now. If you have time to do this survey for us, it'd be really helpful for our research. So please do that if you have the time, and thank you again. It's links there now in the chat box.
Can I do a very quick plug? minute.
Yeah, go for it.
We plastered in the Design Museum last week with a team run by Jeffrey the Natural Builder, and I recommend everyone go and see it. The exhibition's called Waste Age, and we made the plaster using recycled ash from a brickworks and clay. Okay.
I'm really glad you mentioned that. Thank you. Yeah. Brilliant. Thanks very much.